small shop owner has bought in the Santa or in any Raitu Bazaar.
एक ही जगह पे मिलके those type of plastics are known as thermosetting plastics. Comparison, there are 3 types:
up, down, right, left.
I am not inferior to anyone.
We are Tswreis. We are top on the Everest. Congratulations.
I want to be a leader.
A very gracious good afternoon to one and all. Respected principal madams and teachers and my dear Tswreis. Okay friends, my name is Sirisha. I am from 1st MPC. Now I am going to teach the subject is chemistry, which is branch of science and which tends focus on properties of substance and the interreaction between different types of matters, and that reaction involves electrons is called chemistry. Okay? Before going to my topic, I want to raise some more questions. You must have to respond that questions. Okay? Friends, do you know what is meant by orbit? And what is meant by orbital? What is difference between orbit and orbital? And friends, do you know how many orbitals are present? And friends, do you know what are the shapes of them? If you wanted to know, if you wanted to respond to all these questions, you must have to listen my class. Okay? First, what is meant by orbit? A circular path which is present around the nucleus and where the electrons are revolved is called orbit. Okay, are you getting my point? Yes. And what is meant by orbital? A 3-dimensional space, the maximum probability of finding electrons around the nucleus is called orbital. And friends, I want to ask a question. Can you respond that? And friends, how many orbitals are present? Do you know how many orbitals are present? There are 4 types of orbitals are present. Do you know what are them? S orbital, p orbital, d orbital and f orbital. These 4 orbitals are present. Do you know friends what are the shapes of them? Yes, you are right that the shape of s orbital is spherical shape. Observe here, what is the shape of this ball? Spherical shape. And friends, what is the next orbital? The next orbital is p orbital. And what is the shape of p orbital? The shape of p orbital is dumbbell shape. Okay, observe these 2 balloons. What is the shape of these 2 balloons? The shape of these 2 balloons are in dumbbell shape. Yes, the shape of these 2 balloons are in dumbbell shape. Okay friends, what is the next orbital? D orbital. And what is the shape of D orbital? Double dumbbell. Okay, observe these 4 balloons. What is the shape of these 4 balloons? I think you are getting my point. Yes? The shape of d orbital is double dumbbell. Yes? The shape of d orbital is double dumbbell. These are balloons, these orbitals are present in the space. Okay friends, now you have to listen carefully. Now I am going to give an example. By that example, you have to find which topic I am going to teach you. Okay? Friends, I wanted to paint my classroom, but I don't have sufficient colors. I have 4 colors and different quantities. What can I do now? I wanted to paint my classroom. What can I do now? You are absolutely right that by intermixing two colors, we get a new color. Yes, by intermixing 2 colors, we get a new color. By that paint, I able to paint my room. Are you getting my point? Here, intermixing two colors and I getting a new color. Yes, by this topic, by this live example, are you able to find which topic I am going to teach you? You are absolutely right that. Now we are going to discuss about hybridization. Now we are going to discuss about the topic is hybridization. Okay friends, what is mean by hybridization? Hybridization means the intermixing of atomic orbitals of an almost equal energy and their distribution into an equal number of new type of hybrid orbitals is called hybridization. Are you getting my point? Yes, you are right that the intermixing of atomic orbitals of an almost equal energy and their distribution into an equal number of new type of hybrid orbitals is called hybridization. Okay, see this slide. Hybridization is a process of intermixing of atomic orbitals of almost equal energy and their distribution into an equal number of new type of hybrid orbitals is called hybrid orbitals. Okay? And friends, do you know how many hybridizations are involving s orbital and p orbitals? You are right that there are 3 types of hybridizations are involving s orbital and p orbitals. Okay? 3 hybridizations are involving s orbital and p orbital. And okay friends, there are 3 hybridizations are involving s orbital and p orbital. Okay friends, now we are going to discuss about the 3 hybridizations. Okay, see this slide. There are 3 types of hybridizations are involving s and p orbitals. They are sp hybridization, sp2 hybridization, sp3 hybridization. Okay friends, what is meant by sp hybridization? The intermixing of one s orbital and one p orbitals of the outermost shell of an atom is called sp hybridization. Okay, the intermixing of one s orbital and the intermixing of one p orbitals of the outermost shell of an atom is called sp hybridization. Are you getting my point? Okay, this is an example for s orbital. The intermixing of one s orbital and p orbitals of an outermost shell of an atom is called sp hybridization. Then in this process we get 2 hybrid orbitals. Yes, in this process we get 2 hybrid orbitals. Okay, see this video.
Or PZ to give 2 identical hybrid orbitals known as sp or
The
diagonal.
process of intermixing one s orbital and p orbitals of the outermost shell of an atom is called sp hybridization. Yes, in this process s character is 50% and p character is 50%. In this process we get 2 hybrid orbitals. S in sp hybridization we get 2 hybrid orbitals. You have to think these are 3 hybrid orbitals. Okay, the s character is 50% and p character is 50%. This is called sp hybridization. Okay, now we are going to see formation. Now we are going to discuss about formation of beryllium chloride. In beryllium chloride, what is the central atom? In beryllium chloride, the central atom is beryllium. And what is the atomic number of beryllium? The atomic number of beryllium is 4. And what is the electronic configuration of beryllium? 1s2, 2s2, 2. 1s2, 2s2. And what is the electronic configuration of beryllium in ground state? The electronic configuration of beryllium in the excited state is 1s2, 2s1, 2px1. Here, one electron is promoted to 2s2, 2px. How the electron is promoted 2s2, 2px1? Because here there is no sufficient electrons for the bond formation. So, one electron is promoted 2s2, 2px1. Okay? Are you getting my point? And friends, the 2 sp hybrid orbitals of beryllium overlap with p orbitals of 2 chlorine atoms and form 2 sigma bonds. Okay? The two sp orbitals of beryllium overlap with p orbitals of 2 chlorine atoms and form sigma bonds. The bond angle is 180 degrees and shape is linear shape. Okay, observe these balloons. These are 3 hybrid orbitals S, and observe carefully. Here, what is the bond angle here? The bond angle is 180 degrees. And what is the shape of these 2 balloons? The shape of these 2 balloons are in linear. Yes, the shape of these 2 balloons are in linear, and the bond angle is 180 degrees. Are you getting my point? Yes, I think you are understand very well. And friends, observe here. Yes, here the central atom is beryllium, and what are these 2? These are chlorine atoms. S, and what is the shape of these 3 orbitals? These are 2 hybrid orbitals, and the central is beryllium hybrid orbit. And what is the shape of these? Linear shape. And what is the bond angle here? The bond angle is 180 degrees. Are you understand what is meant by sp hybridization? Okay. Now we are going to discuss about sp2 hybridization. Okay friends, see this video clipping on sp hybridization. Here this is called linear hybridization or diagonal hybridization. The central is sp hybrid orbital, and these 2 are p orbitals, and they are overlapping each other and form 180 degrees, and shape is linear. Okay, are you observing that video? The shape is linear and bond angle is 180 degrees. And can you give examples for this? Beryllium chloride, carbon dioxide, beryllium fluoride, acetylene and carbon monoxide. These are the examples for sp hybridization. Okay friends, now we are going to discuss about sp2 hybridization. Okay, what do you mean by sp2 hybridization? The intermixing of 1s orbital and 2p orbitals of the outermost shell of an atom is called sp2 hybridization. Okay, see this video, see this slide. Intermixing of 1s orbital and 2p orbitals of the outermost shell of an atom is called sp2 hybridization. Okay, are you understand? Okay, the intermixing of 1s orbital and intermixing of 2p orbitals. The intermixing of 1s orbital and 2p orbitals is called sp2 hybridization. In this process, we get 3 sp2 hybrid orbitals. Okay, in this process, we get 3 sp2 hybrid orbitals. Okay, observe here. In sp2 hybridization, we get 3 hybrid orbitals. S. Are you observing carefully? These are 3 hybrid orbitals, and are you able to find what is the shape of these 3 hybrid orbitals? Trigonal planar. Trigonal planar. And what is the bond angle here? The bond angle is 120 degrees. Okay, the bond angle is 120 degrees, and the shape is trigonal planar. Okay, see this video. By that you are able to understand very well. The process of intermixing 1s orbital and 2p orbitals to give 3 identical hybrid orbitals is known as sp2 hybridization. In this hybridization, 3 hybrid orbitals are formed. These hybrid orbitals takes the direction of p orbitals. Okay, observe carefully. Here the two p orbitals and one s orbital is intermixing together and going to give 3 hybrid orbitals. And the hybrid orbitals oriented along the 3 corners of regular triangle at the angle is 120 degrees. Hence, this hybridization is called trigonal hybridization. Okay, observe here, what is the bond angle? The bond angle is 120 degrees. And friends, in this S character is 33.33% and P character is 66.67%. Okay, see this slide. Here S character is 33.33% and P character is 66.67%. And can you give examples for that? The examples for sp2 hybridization is boron trichloride and ethylene. These are examples for sp2 hybridization. And observe this diagram. Here 1s orbital is involving, 2p orbitals are involving, and they give 3 identical hybrid orbitals. Okay. And now we are going to see formation of boron trichloride. Okay, formation of boron trichloride. In boron trichloride, what is the central atom? The central atom is boron. And what is the atomic number of boron? The atomic number of boron is 5. And the electronic configuration of boron in the ground state, 1s2, 2s2, 2px1. The electronic configuration of boron in the excited state, 1s2, 2s1, 2px1 and 2py1. Here one electron is promoted to 2s2, 2py orbital. Yes? Observe carefully. Here the central atom is boron and that 3 are chlorine hybrid orbitals, and in the excited state the central atom boron overlap with p orbitals of chlorine. In the excited state the central boron atom undergoes sp2 hybridization and forms 3 sp2 hybrid orbitals and each having single electron. And observe this hybridization. The ground state electronic configuration of boron is 2s2, 2px1. In the excited state electronic configuration of boron is 2s1, 2px1, 2py1. One electron is promoted from 2s to 2py level. Then electronic configuration is 2s1, 2px1, 2py1. Are you getting my point? And 1s orbital and 2p orbitals are overlapping with intermixing together and gives 3 hybrid orbitals. And we get 3 sp2 hybrid orbitals. And now we are going to do electronic configuration of chloride. The atomic number of chlorine is 17. Electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p5. Which is the ground state electronic configuration of pz orbitals is having unpaired electrons. And the 3 hybrid orbitals of boron form 3 sigma bonds and each having single electron. And observe here the bond angle is 120 degrees. And the shape of boron trichloride is trigonal planar. Are you getting my point? Here the central atom is boron. Okay. The 3 sp2 hybrid orbitals of boron overlap with half-filled p orbitals of 3 chlorine atoms in head-on position and form 3 sigma bonds. Yes? Observe here, this is 3 hybrid orbitals and here these are 3 hybrid orbitals in sp2 hybridization, and here the sigma bonds are formed in this place. And friends, are you get here, observe carefully what is the bond angle. Here the bond angle is 120 degrees. Can you able to find what is the shape of this? Trigonal planar. Okay friends, are you understand what is meant by sp2 hybridization? Okay, now we are going to see these in orbitals. Okay, see here, just now we are discussed about sp2 hybridization. Yes? Here, what is the central atom? The central atom is boron. Yes? The central atom is boron. And what are these 3? These are 3 chloride hybrid orbitals. And are you able to find what is the shape of these? Trigonal planar. And are you able to find what is the bond angle here? 120 degrees. I think you understand what is meant by sp2 hybridization. Okay? And now we are going to discuss about sp3 hybridization. Friends, what is meant by sp3 hybridization? The intermixing of 1s orbital and 3p orbitals of the outermost shell of an atom is called sp3 hybridization. Okay? See this slide. The intermixing of 1s orbitals and 3p orbitals of the outermost shell of an atom is called sp2 hybridization. Okay, in this process 1s orbital is involving and 3p orbitals are involving, and these 1s orbital and 3p orbitals intermix and give 4 hybrid orbitals, and give 4 hybrid orbitals is called sp3 hybridization. In this process we get 4 sp3 hybrid orbitals, and the bond angle is 109.5 degrees, and the shape is tetrahedral, and the s character is 25% and p character is 75%. Okay. Observe these 4 balloons. These are 4 hybrid orbitals. Okay. Are you able to find what is the bond angle here? The bond angle is 109.5 degrees. And can you able to find what is the shape of this? Tetrahedral shape. And now we are going to see a video clipping on sp3 hybridization. The intermixing of 1s orbital and intermixing of 3p orbitals of the outermost shell of an atom and forms 4 hybrid orbitals. Okay, observe carefully in the video. Here the 1s orbitals and 1s orbital and 3p orbitals intermixing together and going to give 4 hybrid orbitals. And here it was given 4 hybrid orbitals. Yes. In this, s character is 25% and p character is 75%. And are you able to find what is the bond angle here? 109.5 degrees. Okay. This hybridization is known as tetrahedral hybridization. Okay. Now we are going to see characteristics of sp3 hybridization. sp3 hybrid orbitals are bigger than sp2 and sp hybrid orbitals. Therefore, the shape of sp3 hybridization atom is formed tetrahedral hybridization. In this process, we get 109.5 degrees. Okay. And friends, can you give examples for sp3 hybridization? The examples for sp3 hybridization is methane, water, ammonia, etc. And friends, now we are going to see the formation of methane. Okay, what is the formula of methane? CH4. Yes, in CH4, what is the central atom? Carbon is the central atom. And do you know what is the electronic configuration of carbon? The electronic configuration of carbon in the ground state is 1s2, 2s2, 2p2. In the excited state, the central atom carbon undergoes sp3 hybridization and forms 4 sp3 hybrid orbitals and each having single electron. Okay. In the excited state, the central atom carbon undergoes sp3 hybridization and forms 4 sp3 hybrid orbitals and each having single electron. The 4 sp3 hybrid orbitals of carbon overlap with half-filled s orbitals of 4 hydrogen atoms in head-on position and form 4 sigma bonds. And just now we have discussed the bond angle of sp3 hybridization. The bond angle is 109.5 degrees and the shape of CH4 molecule is tetrahedral. Observe this diagram carefully. What is the central atom? The central atom is carbon. And how many sigma bonds are formed here? You are right that there are 4 sigma bonds are formed. And friends, are you observing what is the shape of s orbital sp3 hybridization? The shape is tetrahedral. And what is the bond angle here? 109.5 degrees. And friends, see this video clipping on sp3 hybridization. Here now we are taking methane molecule. The central is carbon and central atom is carbon, and we get in this process we get 4 hybrid orbitals. And 4 sp3 hybrid orbitals are directed towards 4 corners of regular tetrahedron with p direction. Therefore, the shape of methane molecule is tetrahedral. Okay, are you observing shape of this methane? Yes? Okay. Okay friends, are you understand what is meant by sp2 hybridization? I think you are understand what is meant by sp3 hybridization. Yes? And friends, are you understand the 3 hybridizations which are involved in s orbital and p orbital? I think you are understand in the 3 hybridizations. Okay, now we are going to see an example. Okay friends, what is the shape of these 4 molecules? Tetrahedral. And in the what is central atom? The central atom is carbon. And what are these 4 atoms? These 4 are hydrogen atoms. Okay. And are you able to find what is the shape of these 4 orbitals? The shape of these 4 the shape of these 4 atoms is tetrahedral. And are you able to find what is the bond angle here? 109.5 degrees. I think you are understand very well what is meant by sp hybridization and sp2 hybridization, sp3 hybridization. Okay. Okay friends, are you have any more doubts on this topic? Thank you for giving this marvelous opportunity to me.